Hello everyone, welcome to episode 11 of Scala Project from Scratch. Yes, it's already been 11 episodes. In this one we continue what we worked on in the last 2 episodes, so streaming events from the server to the client, making them, like these events, these messages can actually just show up on the client. We also do some testing, some more functional stuff. We define a traverse instance and we also test it with the CAD's test kit in Weaver. So without further ado, let's get to the video. Alright, so last time we did a lot of work on error handling and resource safety. Like we actually fixed a pretty important issue in how the client fetched the stream of the response. And today I wanted to just clean up all the streaming stuff, see if we can further extract some of the business logic from the, like maybe not business logic, but some of the decoding logic from the protocol object. We'll add some messages that will be actually streamed just to finish up all the streaming code, possibly some streamed output, and the last thing that we'll do in the series will be the custom build file format. But first, as always, we'll go through pull requests, and today we actually have a pull request from one of the viewers who is not Scala steward. So basically the whole purpose of this PR is instead of using the fs2.compiler constraint, we will just be using the concurrent constraint. One of the main reasons why compiler should not be used directly is that it is technically possible to get a compiler for the same effect in 2 different ways. Like you can get a compiler if you just have a sync constraint, and you can also get one if you have a compiler constraint. And it's generally just better to have the concurrent constraint in scope so that you always get the right compiler. Like HTTP4S has some issues sometimes when you use the sync compiler. There's actually a ticket open with some, there's a bunch of discussion on that, so it's just the easiest to just do this. So I'm gonna merge this right now, and we'll go on to the Scala steward PRs. Just merging. And yeah, next to that, we have a couple Scala steward PRs. I think I also accidentally merged some off stream. These are just some FS2 updates. So I think this one is actually not just FS2, but an STTP integration for FS2. It was just a patch update. And then we have an actual FS2 update, which is also a patch version. And yeah, one was closed because I think there's a new pull request now. So yeah, let's look at the open ones and get them closed real quick. So I'm gonna fetch the steward branch, the steward remote, and we're gonna do updates 2206. I think I mentioned last episode that this was going to be an episode in May. Well, it's not May anymore, but we are barely into June. I hope you are okay with this, but I still want to finish this series this month, so we'll be in quite a hurry to finish. So all these PRs are green according to CI, and also we'll see if there are conflicts, but I don't expect many, like probably in the build, but they shouldn't semantically conflict. So I'm just gonna try to merge all of them into a single branch, and then try to run all the tests on that and see if we can just merge all of it at once. So this is Scala FNT 353. We're also gonna have top here 022 and FS2 362 and cast effect 3312. Weaver 0712 and HTTP4S. This one. Let's see if we can get all of them, and we cannot. So this is a conflict. Let's just pick these versions. That was all of it, right? The only conflict. Yeah. Okay. Now let me just push this, and we'll get the CI to do the dirty work for us. And let's see. I'm Just gonna close all these tabs and we can start talking about the plans for today. So, yeah, I already mentioned this. So to clean up the streaming, I'm gonna go to this place with a bunch of to-dos. So first we need to actually have some stuff to stream. So while we build, I was thinking to just try to output some events like what step we are executing right now. And I believe that this would be in the interpreter. Yeah, let's actually try to see. Yeah, I think the interpreter is the right place, like the one that actually does all the dirty work. So it just returns an effect right now, and interpret is called certainly somewhere. Sadly, we cannot search for this between modules in metals, but yeah, the interpreter I guess will be in the server-side executor. There it is. So yeah, we just lift all this to a stream, even though we have just a single effect. So I'm thinking to just change this method to return a stream, do the events inside, and then get rid of this and, you know, just enter stream world. We can do this without any actual like additions. We can simply like just change this interface, change the call site, and then we can add the messages that we'll be streaming later on. Let's see how the CI goes here. Yeah, it's still not done. So yeah, I'll just start doing this in that branch, then we can stash and get back to main. Yeah, let's do it. So interpret will need to return a stream, so let's do it. Stream f system state, and now it's a system state, but I don't think I want it to be a system state. I'll actually want output event, which I think now has just one type parameter, yeah. And we'll just add log messages in the meantime. So let's just change the signature, output event. And yeah, now like this is all like pure, so I'm gonna have to lift it to a stream like this. That's probably the easiest way. And of course, this is just this is not just a value; it's an output event with the value. So this will be a result. Yeah, and now we need to update the call site and all the tests. So I'll remove this eval, or actually I'll wrap the resolve part. Then we can flat map to an actual stream. And this will be an eval map. Now this attempt to narrow, let me see like why we had this in the first place. So I think if the interpretation failed, which it cannot, but the resolver could, if you had any build error, right, we would wrap that. The whole output event can contain this either, right? Makes sense. So we'll need to get rid of this for sure. What else? Interpret gives us a system state. Yeah, you know what? Let's just forget the errors for now and get this all to compile. Okay. I think I know what the problem is. So this returns an output event or system state, and then if that is a success, we want to continue with what was in the output event and call the save function. So we can, you know, do it really quickly in a quick and dirty way. So output event, and I can do like a pattern match on it. I think I should be able to do it. Okay, let's just do output event result. And if it's yeah, something like this, we can run the effect. Otherwise, yeah, let's just ignore that. The other cases. What else? Oh yeah, and we need to map this to output event result, but also do like an as write in here to convert it to an either. And What else is wrong? Instance. Okay, I'm not following this. Unit. Probably like a indentation issue. So this still belongs to the body of build. Does that match anything? No. Yeah, we just had one brace too many. So this needs to stay here for now. We'll need to fix it at some point. Yeah, so this is kind of tedious, right? We have to pattern match on the output event and unpack this value and then wrap it again. So I'm thinking to do it like this whole pattern is usually done in a traverse. For example, when you have an option of string and you have a sum, and then you want to do like match. Okay, sum v. You do something like some effect, and then you map with sum again. And if you have none, you do non-pure whatever. Like this would be an f of maybe int, whatever. Yeah. So this whole thing will be an f of option of int. Yeah, so this whole pattern of unwrapping and then wrapping again, this is traverse. And also like doing this. So traverse v, and you don't even map it here. So this is gonna give you the same shape. So it would be nice to make our output event traversable. Let's see if we can do it. So we already have a functor, which is good, and we can try to extend it to a traversable, to a traverse, yeah. What else do we need? By the way, this is like a new feature in Metals. In Scala 3, we can finally implement methods this way. So I'm quite happy about that. Is that the right shape? I think we also need like fold left, yeah, fold left, fold right. Left, fold left, fold right. Yeah, we'll need to implement these. It's not going to be very difficult because this is not like a list-like structure. It's more like an either-like structure. So in general, folds are very easy to implement on these. And map is no longer necessary because it will be like a default method derived from traverse. I think map is just traverse with identity. Of course, some stuff is breaking the interpreter, which makes sense because we changed the signature of the function. At this point, we should be able to merge this, and we are. Let's merge. Yeah, and at this point, we have no remaining pull requests. So let me stash this, get back to main, and unstash. And we have a conflict. Yeah, because I didn't actually update to this concurrent change. But I think this will be enough. Let's import. Looks right. So, yeah, we were looking at this and the traverse instance. Yeah, so let's try to implement maybe the easy ones first, the folds. So, given an output event and the B that we'll be starting the fold from, we need to like combine these values. By the way, we should be doing lol tests on this, and I'm inclined to start doing it because this is not like a non-trivial instance. So yeah, we should probably try that. Anyway, for now, let's just implement the instance. So I'm gonna match on this, and if it's an output event, actually just a log message, it doesn't matter what's inside. We just want to return like the same thing. So this will, I'm not even sure if we can do it like this, but let's try. We have an applicative of G, so I can do ln pure G. Yeah, and I cannot, because this is a log message of A, and it should be an output event of B. Now the question is why it's not. Because I would assume that this can be, you know, widened, maybe this way. Okay, no. What if I say this is an output event of B? What if it's a log message of B? Oops. Yeah, so Scala 3 doesn't like this. You know, I was thinking this is like none in Scala 2, where it's an option of nothing, and option is also covariance, so this would work like this kind of widening. But apparently Scala 3 enums don't work exactly this way. But yeah, that's okay. We can just make another log message like this, yeah. So I'm gonna do it this way for all the other kinds. So failure, it's also gonna be a failure. G. And now finally the result. We're gonna do f of v, and now we're gonna map to result. So this is effectively what we were doing in here, right? Except we will be able to reuse this for any kind of applicative effect and also in other abstractions. Now we need the fold left and the fold right. They are effectively the same, just like a different evaluation order. So I'm gonna match again. And let me just copy paste this real quick. So these cases both, the failed ones, I think we can just merge into one case. So log message was failure. We can just return B because there's no way to get an A, so we cannot call this function. This is the only thing that we can possibly do. But here we have an A, so we can actually call F with the B and the V, which is an A, like an instance of A, and return that. That's actually the whole implementation. Fold right is going to be a little more convoluted, I think, because of the eval. If you are not familiar with it, eval is like a data structure that allows you to lift laziness to the type level. So it's like eval now, this is evaluated immediately, but eval later is going to be eval just like, you know, at some later point in time. You can also do like always, which will, like if you have this, and if you do dot value, this will, like when you call this, that's when the 42 will be evaluated. Like when you do print line here, and you do this a couple times, you'll only print once, but the value will be kept in all of these. So it's kind of like a synchronous future. Well, not really, just, yeah, forget that. But if you do eval always, it will actually run the print line 3 times. So yeah, that's what it is. And eval is also a MUnit, so we can flat map on it. That's the whole point of it here. So fold right is, yeah, usually deals with some lateness, so this is how it works here. Okay, so if it's, let's do the result first. If it's a V, I think now we should be doing F with the V and with the initial value, like the 0. And this is the whole result. By the way, did we always have this, like exhaustive checking in Scala 3? Because I can't remember. Because Scala 3, as I have to complain about in every episode, Scala 3 does not have many linting options, like many warnings for your code. So I'm really surprised to see this one, but this is actually really good to have. So let's do the other cases. I think it's going to be the same as previously. We can just return all B, actually. I think we can. Let's see. Yeah, I don't see a reason why we would be actually evaluating any of this or flat mapping. This seems like a good implementation. But yeah, I'm gonna load test it. So we are using Weaver, right? So Scala check. Is there any integration? Not even Weaver, not even Scala check. I want discipline. So there is something like that, but is it actually provided by Weaver? It is. Yeah, I think I asked about this a long time ago. So it's good that it's there. And yeah, I'm just gonna do it right now. So Weaver and Weaver discipline. And because we're gonna deal with Scala check, I'm thinking to add Magnolify. I just don't know if it's supported on Scala 3 yet. So this is a collection of like Magnolia derivations for several libraries, like Scala check, so that we'll get the arbitrary instance, and also cats, like eq instances. So the question is whether this is supported in Scala 3. Just look through the issues. Yeah, sometimes it's the easiest way to find out. I didn't actually want to reload. The easiest way to find out whether a library is supported is to just try to use it. So, Magnolify. Let's get the cats and the Scala check versions. And I think this is the latest. Also, yeah, this is fine. So let's just make sure we get these in the test scope. Although I guess the cats one can be in the normal scope. And let's see in SBT. Okay, let's try updating. And it's not there, so let's see if there's actually any version on this. Yeah, it doesn't look like it. I don't think Magnolify is supported in Scala 3 at all. I don't see a ticket either. Is there a pull request? Nope. Yeah, so I don't know. Like we could use kittens for the cats part, and I don't know, Scala 3, Scala check. There's Scala check shapeless, and I guess shapeless is better in Scala 3. But also I'm not even sure if it was released. And if this was released for Scala 3. We could actually write the derivation ourselves, it's not really that difficult. But yeah, I think I'm just gonna define the values myself. So we'll just get rid of this, we'll define eq and arbitrary on our own. So, output event is currently defined in the shared module, which I think it's gonna stay there. So we're gonna have this. Let's see how they wanted us to implement it in Weaver. Yeah, I'm just gonna copy paste this because why not? And yeah, of course we're gonna need cats loss. And do we have a cat score dependency? Like a direct one? Not that I know of. Yeah, I'm gonna get one. 2.8.2.7.2.7.0. And I'm gonna put it next to discipline. It might be time very soon to split this whole list of dependencies somehow. Also, we should eventually look at native image again. It recently gained support on M1 Max, so I finally have the chance to play with it on this machine. Yeah. All right, this compiles apparently. I'm actually gonna run these tests. Yeah, seems to run. So this is supposed to be called output event tests. And I'm gonna just try to test traverse output event, traverse tests. Output event, traverse. Of course, this is not going to compile because we don't even expose this instance as a traverse. It was a functor. Can I do... I think there's like some new syntax for this. So given traverse output event with... I think that's it. Yeah, that's pretty cool. Also, we have an eq. That's nice. So now it wants... Oh yeah, I need to specify some values. So let's try with int, string, and boolean. It wants another one. Oh my god, there's like 6. Right, so we need like 4 normal types, then a commutative applicative, and another one. Yeah, it's been a while since I tried this, so what would be an example commutative applicative? Like a parallel I/O would be one, but I don't want to deal with I/O in these tests. Yeah, I can actually search through the code base. That's gonna be the easiest way. Of the cat's code base. So validated is one. Yeah, which makes sense. Then we have const. And zip stream. So I think I'll use just validated for now. Let's just use another int and validated nil of string. That's data validated nil. And we need one more. Maybe the same one. So there is no commutative applicative for this. Is that because string is not commutative? No. Yeah, So validated has a commutative applicative when. Commutative semigroup. Okay, let's try just int without the null. Okay, what's this? Is metals misbehaving again? Yup. Okay, now we're just missing arbitraries. But also I don't like this, like maybe... can I use another type? The zip stream. Zip lazy list. Okay, so now we just need an arbitrary. So let's try to define that. Arbitrary output event A. And an arbitrary validated in string. So I think this is in Katzlaw's discipline. Okay. This is somewhere, like these instances are there. I'm not sure where exactly though. So discipline here. Laws. Like where did it get and where do we get all the cats arbitraries? Arbitrary instances. Arbitrary, okay. Yep, that was enough. So let's implement this finally, and yeah, I think we'll do... Oh right, this is an ADT. So arbitrary one off, and let's see. So we have gen result of output event result. So this is like my favorite way to define a gen for a case class quite easily. You just pass like a function that produces the value, and you don't need to, do any kind of manual work. You don't need to use macros to derive. This is defined for, I believe, a function of every shape. Maybe not. No, for just functions, okay, of just one argument. So I guess if we had more arguments, we'd do like tupled. I think so. Anyway, so you don't need to write, like normally you would say like for an arbitrary A, we would do output event result of A. So we don't have to do this, like deal with the exact types, just say result of A. And that's one case. We have two more. This one will be log message, and it doesn't even need an A. And this will be failure. Maybe we can use apply. Yeah, now it's complaining about arbitrary generic server error. Do we have one? We only have an eq. Yeah, we're gonna need this arbitrary at some point, so we might as well define it here. So generic server error, that's effectively just a string. It happens to be an exception, but yeah, it's not very important. So here is like another example of gen result of. So arbitrary of generic server error equals arbitrary gen result of. That's it, right? So that's quite convenient, and no macros, fast to compile. Like it does deal with implicits, but that's not much of a problem in here. Let's see if this test, that these instances were correct. Yeah, it takes a while. Okay, I'm not too optimistic about this. Is this actually doing anything? The big question. Okay, I'm just gonna stop that. Yeah, let's actually try to run the test in SBT. So shared test only Steve output event tests. Just in case Bloop has some issues, but I think this might actually be a problem with our instance or the way we have written the tests. Still compiling. For real? No, it's actually running. Okay. Okay, out of memory. Yeah, that makes sense. Is it like a... Yeah, just heap space. So let's look at this. Like, any issues with that? FV, like, I believe this is correct. Let's see just the functor test for now, okay? So, functor. Yeah, just like that. Yeah, that worked. What else can we do? A traverse test. This extends from functor tests, foldable tests. Let's try foldable tests. So we need just two. Okay, maybe int. That is also correct. So it's the traverse that's like a problem. Interesting. So what's the eq of generic server error? It's just like from universal equals, which I think will be based on the message. Yeah, honestly, I have no clue why this was a problem. Probably, oh yeah, it's the zip lazy list. Zip lazy list has a problematic instance because like the pure of it, I think, is an infinite list. Let's just use validated twice. I'm not exactly sure why this is, why it shows up twice, but yeah, immediately successful. Wonder what other folks use. So in cats, traverse tests. They use option. Yeah, that's also a reasonable instance, I guess. Let's use option here, maybe in the first one. So option is a commutative applicative, really. Option instances. No. Cats. So where's this coming from? Commutative monad. Okay, so there's a commutative monad for an option always. Very interesting. But I guess it makes sense, yeah. Cool. Yeah, we'll just keep using this. By the way, here's the metals bug. I can change, add the implicits here. And when I do it, it says it's trying to change the bloop JVM properties, which might not be an issue in itself, but the problem is it shows that these hidden, these implicits, and when I try to disable it, I have to jump to a different file and back. I don't know why. Anyway, I'll look into why it tries to modify the global settings at some point, but not now. Anyway, we have the instance and it is lawful, so that's really good to know. So let's get back to output event. So we have this instance, and what we wanted it for is this. So I can simplify this code to just say traverse. And with a V, we want to traverse like this. Same type, okay? And we wanted to catch all the errors. The question is where we would do that. Because if there's an error in resolution, then we want to keep it. But also interpret could possibly fail. So this should actually be an either here. But either of a builder, yeah, I guess. So we have an either builder here and also in the implementation. And this is going to be a write. Okay, now, yeah, so we have an either here, so we need to traverse again. So we traverse. And we will do something like this. So what I'm saying is if there's a write, then also traverse on it. Like save it and then wrap the result in a write. If there's a left, just put it in an effect and return the left. So the types make sense, but this attempt narrow, I don't think we need this anymore on the whole method. So just in case the resolve fails, we want to lift this to an output event. Right? So I think I need to put this here. Also, what if interpret fails? Then it goes to the output event, okay. And what if save fails? Yeah, we can deal with this at some later point. So now we need to get this to compile. So let's see what we need to get. I assume this will be an either. An either of build error and result build. So what if I do, let's see, can I traverse? That's question one. What do I get out of this? So that's a stream of either with an output event with an either. How about flat traverse? That's not the right shape yet. So I'll have to map on this. And can I flat sequence here? No. Again, we have an either. With an output event of either build error or system state. And what we need is an output event, like get rid of this external either. We want this. Or do we? Yeah. So why didn't flat traverse work again? Because this is returning output event, sorry, stream of, oh, flat traverse. Yeah, we would need to return an either at the outside. So what if I do this, but I like sequence here? That's an either. What's wrong here? Like, okay. Found F either. Output event is, yeah. These are strange types. I can tell you this. It would be nice if you could like merge output event with an either. And at some point, I think I'll just do it, bite the bullet and do it. So we'll have 4 kinds here. But this will require adding a second type parameter, which I don't really want to do yet. So let's just try to get it to work this way. Let's see if this type makes sense. I think it does. But didn't this used to work? Oh, the output event here is the wrong type. So I think I want to sequence this first so that I have, yeah. No, wait. No. What if I do sequence here? For real, what's wrong? It doesn't have an applicative for... Oh, we don't have an applicative for output event. Now, is this gonna be a problem? Who knows? Okay, let me just try to implement this with no traverses, no nothing, just get it to work. So this is supposed to be an output event of either build error and output and system state. Like if we have this, then we'll be fine. Really? Wait, what is this? Okay, yeah, the problem is here, actually. Can I do this? Okay. So this was okay. Yeah, this was okay. All right, so for this to make sense, this will have to be that type, right? No? a stream of that. Okay, we're getting there. I'm telling you. Flat map. What's wrong again? Why does it want an either? What? Maybe this way? Yeah, okay. We're getting there. Don't worry. So I can do this. And yeah, like that, this is the tough part. So here we have the result build, which is an either. So if this is a left, then we want a single element stream, which is an output event or result left E. If it's a right, then this is just a value, and we can do this interpretation. And that's a stream of output events of the right shape, right? Yeah, that's all of it. Okay. Now, can we simplify this? Because I think like only the left case actually looks similar to what you would see in a traverse, but the right is kind of like a map more than, yeah, I don't know, maybe this is like a fold. Not really. It's a left traverse maybe. So there's also something like that. So if we do this, let's see. Nah, not really. Like we would need to first map to this. Maybe. Just trying it out for now. Nah, that doesn't work. Yeah, I'm just gonna keep it this way because honestly it's not that terrible. It's actually some decent code. Can I do this again? System state. Yeah, so we can do this on eithers, I think, but not this way. Ah, right. So with right only works. Wait, why doesn't this work? I should be able to just like use with right with any other type, no? Like B1 shouldn't have any constraint like this. Strange. So yeah, I'm not gonna do it. So we're gonna just rewrap like that. Okay, yeah, I'm just gonna assume this works, so we can try seeing later with some tests of the server-side executor. But for that, we need to compile this or disable it, and I'll disable it for now just to run the other tests. So server, let's run all that. Okay, so the server-side executor tests still pass. Yeah. Cool. So let's get this to compile again. So this old method, I think this was on, oh yeah, we have an interpreter of ID. So this is gonna be fun. So we need to go from a stream to the system state somehow. Yeah, this is also like, these are not very unit-like tests. They're like, if you interpret, I guess they are, but we don't look at the whole result, which is, I think, a map. Like the system state is a wrapper over a map. We're not exactly looking at this, we're looking at the result of this, like getting a specific key from this map. So, in summary, we want the last element, which is also supposed to be a result. And I think we had an extractor for this somewhere. Not exactly sure where. Maybe here? No. We definitely had something like that for extracting this thing. Maybe it was on output event. Yeah, it's get result. So I want this, but it doesn't only works for concurrent. So I think, yeah, we'll have to get rid of this ID. Let's just use IO and property for all. This is a MUnit. Yeah, we need to change this to Weaver. Scala checkers, okay. And this is prop for all, just for all, yeah, I think. So we'll have, yeah, let me just steal this from here. So we have test for all, and this is in a simple IO suite. Test for all, assert equal. Yeah, so this will need to do like get result on this. Output event, get result. Right. So result. Actually, can we lift build.error? Is that a throwable? Yeah. So rethrow. I'll need some cast implicits. So rethrow, system state. Something like that. Now, what's the issue here? Let's just try to compile this one test. No implicit argument of IO expectations to Scala check prop. This is a different for all. Yeah. Let's try that test. Okay, it failed. This is a class, it should be an object. Thank God this is implemented, because I would be looking for the cause for ages. Yeah, this works. Let's try the others. So, not a very straightforward conversion, but maybe let's define like a utility. Result, something like that, and we can just pass a build, I think. So we'll do all of this. Yeah. And we'll pass the build here, and this is it. Again, test for all. Build map state. Yeah, something like that. Let me just do the other tests as well. Okay, now there's two builds and we want the whole results. So I think I just do let's do build and build 2 by traverse. Interpret result. And we want to ensure they are equal, so assert equal. Yeah, map n is, oh yeah, we don't need to map n, we need just map. Yeah. I think this only works, by the way, because this is Scala 3. Like normally you would have to do, you know, it's AB, just pass these two values here. But this is like automatically untoppling here. Like this, what we are doing is effectively that, like without the case word. And this can always be desugared to this in Scala. So that's quite nice. Alternatively, we could do like by map here and map n, but I like this one more. And let's see, still passing. Test for all. And this is gonna be, wait, is that the same test? No, but we can copy paste the same logic. And yeah, let me look at this one. So we have one build that we interpret and another one. Oh yeah, this is like a double interpret, okay. So this is gonna be interpret result of this build. And that's gonna be sys1. Yeah, and then we interpret again. So this one more commands. And this has to be the same as interpreting this. Yep. Of course, this is gonna be test and for all. And here we'll do part of this. So LHS, RHS, and I think just assert equal on both sides. No. That's the system state and that's the system state. This is a map n. Yeah. And we just need a show. Why do we need a show though? Because it's generated? Like that, it's one of the inputs, is that it? Yeah, I think so. Okay, yeah, that's fine. Like we just need a show of result build command. I can define it here. Yep, and the test pass. By the way, have you noticed like how fast Weaver is? Like I always feel like it's really, really fast. Yeah. Just checking how long we've been doing this. I think it's, yeah, we're around the 1 hour mark. So let's see what else we can do today. Actually, I think like we are around the time we can actually commit. So yeah, we added this discipline, we added, we made the interpreter aware of streams. We are this close to actually adding some events to it. And I think we should do it. Just looking for this. The traverse instance, yeah. So I'm gonna say this. I could actually split this into 2 commits, so I'm gonna do it here just to show like how I would do it. So I have a bunch of changes here in my Git repo, and I have a new file, and I have some changes here that I think I can actually split meaningfully into a couple of commits. So I'm just gonna make a new branch for now. We're gonna call it episode 11. And I'm gonna do, like you can do it in VS Code or whatever, or your editor, whatever it is. I'll do it in Git. So I'm gonna run an interactive add. And then I say patch, and I'm gonna say 1 to 6 to get all the files. And then I just like use these commands like yes, no, quit. I think it's all done and something else. Yeah, it's like do not stage this or any in the file. Yeah, I usually use the first couple. So do I want this change? Yes. Do I want this? No. 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 Now what's the show here for? This is for this result build command, so I don't want this yet. I'm just gonna do like the traverse instance here. No. No. Yes. Although the eval, it shouldn't be here. No, actually it should. We need it. So I'm gonna check it in. This as well. I can also like split this whole thing, and now I have more fine-grained control over what I want to add to my commit. So I want this, yes, and we're almost done. Like, we just need to add this file because it apparently interactive add doesn't allow you to add a new file like this. Maybe there's like you need to pass some more commands, but I can just add this file explicitly. And now I would like to just stash the unstaged changes. Let me actually Google it. Git stash -k. Okay, I'm gonna risk everything and do it. Okay, it seems to have worked. And now I can just test everything just to make sure that my first commit works. I think I should do an SPT reload, but I didn't actually add make any changes that I did not add to my commit. So yeah, this is all I did. So this is just gonna be like add traverse instance for output event. Yeah, I'm gonna push it so that CI checks it again for me. And now I can pop the stash, and these are the other changes. Do we actually have any MUnit left? We have one more. Okay. So yeah, this is just making the interpreter aware of streams, events. Yeah. And I will push that as well. Now I really want to get rid of MUnit just to, let's see how much we need to get rid of. That's one test. Yeah, it's definitely going away. So let's just do it real quick. While the CI runs. MUnit, nope. Simple IO suite. Like, I have nothing against MUnit, it's just that I want to use one framework, and Weaver just interacts better with effects and properties. So I could actually define an assert IO of my own, but I don't want to. So we'll map on this and do assert equal with output like this. I'm probably, yeah, there's too many braces, parents, output, just indentation. And does that actually work? Server, routing tests. Okay, again, this is a class. And let's break it just to be sure, like v2. Yeah, it works. Okay, we can actually try to get rid of MUnit from the dependencies. Re-import and do it again. And test everything again. Okay, by the way, does this change anything? I wonder if the parallel test running would be faster on the whole thing. 11 seconds, for real. Doesn't feel like 11 or 10 seconds. It might be like adding all the time. Let's do that in SPT just to check. I think SPT will run suites in parallel. Not even sure about that. Let's see. I should have compiled first. Again, test. Yeah, that's pretty fast. 4 seconds to run all the tests. Yeah, cool. I'm actually gonna move this Weaver migration to this episode. So episode 11. We have a migration to Weaver. We have prepare to do more streaming and traverse instance for output event. Okay, remove MUnit. Let's see the CI. So far all the other commits on this branch were fine. We can go to the branch episode 11 and see the list of commits to see their progress. Green, green, and this one is running. Should be green as well. So I think, yeah, let's look at what else we can do today. I mentioned possibly adding some events to this. And yeah, I think let's do it. So for every command, I'm gonna have one event, like just saying what happens in the command. And output event is currently just string based in the log messages, which is fine, but at some point we should probably do, you know, like some log level. So let's add some actual messages in there. So for each one of these, like I think the state thing might not be enough for us anymore. Maybe we'll do state D. Yeah, I think like a state D will be an easy transition. And maybe let's try to test drive this a little. So in the test of the interpreter, I want to make sure that if I have like a, this is not even going to be a property. Let's just do a normal test. So upsert plus delete emit events, or just upsert emits event. We can actually do like 2 separate tests for that. So I think we can do it with one specific case. So again, I think for this I can actually use an interpreter ID. Let's just write it, you know, any way that compiles and see how to get to a simpler thing. So I'll have upsert with like key and value. And this, when I convert it to list, system, what's system? It actually doesn't matter, I think. Yeah. So this will actually be generated by Scala check. System state. Okay, I cannot do to list. That's interesting. Why not? I thought I could do it for an FS2 stream. Compile to list. Yeah, okay, that works. So I have a list of all the events. So I think I should just assert that this contains this event, like upserting this. So contains upsert. Sorry, this is gonna be an output event. Log message. Yeah, just something like that. Of course, yeah, that's not even gonna be an interpolation, just key and value. Events. And this is gonna be my assertion, I think. So assert event contains that. I think this will have to go to a pure or not. Let's see. So this is in the server package and it's an interpreter test. Okay, it failed with a really weird message. I think it messed up my terminal. Let's do it again. Let's actually do it outside of VS Code, just because this terminal does a lot of weird stuff sometimes. So let's do it again. Yeah, it breaks on some arbitrary stuff. And I think that's because we indeed did not just provide a log message like that. So first of all, I want to change the arbitrary so that they don't come up with some weird stuff like this. I want ASCII. So arbitraries. Let's define an arbitrary of string, like redefine it. So ASCII string. Is that gonna help? It is gonna help, but it's still not enough. Can we do identifier? Yeah, that's better. And yeah, I'm not sure like if this is fine. Technically, we are vastly reducing the amount of strings that we're gonna test, but at least they will show up nicely in the terminal. So like probably don't do it for all the strings in your code base, but here I'm gonna do it because we don't do much string editing or persistence, so it doesn't really matter much. So that's like a trade-off that I'm making here. So yeah, let's have another test for absurd. Actually, I don't think that's the TDD way. Let's just do one test like this. And let's try to implement that so that it passes. What if I do emits? This is like my final result. Or just stream, yeah. And this is my second event, but we'll also have one here, output event, log message. What was the message? Absurding. Okay, v. Yeah, like this should pass the test. Yeah. So now, of course, this is not the correct implementation, so I'm gonna have to change the tests, like have another one that will make sure this doesn't pass. So maybe now we can add a delete in this event. So if you have a delete here, we'll have deleting, okay. And now the tests fail. Yeah, now I should fix this test. So we can do it in here. Right now, the state returns just unit. I think we could actually do like a log message here for now. Output event log message of anything. What's the right? Yeah, I think this is the syntax. Okay, what's the problem here? Like, why does it say any? Like, oh, is this because this is like a kind projector syntax? No? No. Can I do any? Or nothing? What's this? Like, what? Like, this should be... The input to upsert should be a system state, right? Oh, yeah, something stranger happened here. Anyway, I'm just gonna do like as and log message, output event, log message, upserting, okay, v. Okay, almost there. So modify takes one type parameter, which is gonna say it's a system state. And system state again as this kind of event. I mean, a different kind of event now. Deleting K. Let's clean up a bit. And the tests are still failing. I think because I ignored this output, this log message. So let's make sure that we take it. So this is gonna have to be changed. And now the commands, the traversal here, I think I want to actually collect all these values. Let's see, transition, yeah. So this traversal will actually ignore all these values. Let's see what the best way would be. Yeah, one thing I could do is probably eval map on a stream. I think that works. So what I mean is, let's comment this out for now. So commands, if I lift that to a stream, commits, and then do like eval map, transition. Yeah, that is something, right? That is a stream of states, yeah. And now I could do, all right, I cannot translate the stream to that. Yeah, I think I know what to do. I finally know what to do. I'm gonna use a ref to store like the current system state in a way that will allow me to emit things into the stream. I think that is the way to go here. So I'll need a ref make constraint, and here I'll make yeah, just ref f off, and we're gonna start with the initial state, right? So build base. So that's my state. State. This will need to go to a stream. Stream eval. And inside we have this like state ref. And now I'm gonna traverse, not even traverse, take all these commands and eval map to the transition with the state ref in here. However, now I need to pass this state ref to the transition, and this is no longer gonna be a state monad. So state ref, this will be a ref of f and system state. And this will be just an f. And this is actually gonna be nicer. State ref, this is actually gonna be more convenient. So modify or update, yeah, just update. That's basically all it is. Now what's the type here? Stream of f of log message nothing. Yeah, and at the end we can append stream eval state ref get. So that's almost it, except now I need to lift this to an either. By the way, like this still cannot fail, so that's cool. That's actually very useful for us. So final state maybe. This will be an output event result final state as right. And because we are in a monadic world, we can move this map outside without changing the behavior. And I think that should be it for now. What's the problem here? Final state was the type object. Oh yeah, I need to actually lift this to a output event result here. And I think here I can just do a map as right. So this will map on the output event or not. So what's the type here? Any. Holy shit. So let's call this LHS. And this will be RHS. What? I just want, oh yeah, I think I need to do this. Yeah. Indentation-based syntax in Scala 3 is still not there, I think. So this is a stream of log message, nothing. This is a stream of output event. Oh, I want emit. No, wait, I want, that's an insane type. This is an output event with an effect inside. I completely wrecked this. So let's do eval and then we'll map to that. That's what I wanted to do. Yeah, that's more like it. So what's the result of the whole concatenation? It's good, yeah. Okay, makes sense. It doesn't pass the test. Yeah, we'll need ref make and the ID tests. Like honestly, I don't think we can avoid the concurrent constraints if we're gonna deal with like events that are emitted, you know, after some time passes. So I guess we just have to bite the bullet and do do IO everywhere. So about to list map result. Sorry, events here. Here's the same thing. Something like that. And it passes, so we are almost there. Now I guess we want to ensure that when we have multiple events, they will also be like kept in this list. That's another thing that I would like to have. Like another guarantee, like many multiple build commands, because emit multiple events. So I want to have an upsert and then delete. So I want, yeah, I think I can do it this way. But also, like this will pass immediately. No? Wait, what did I do? Can I try recompiling? It says delete k, deleting. There we go. Yeah, the problem is it doesn't check like the order. So I think at this point we can probably just like verify the whole result. So expected, what we really expect to see in the list is output event, like these two. These two and then a result. But I don't really care about what is in the result. I guess I can collect all the output events, which would make sense. Let's do that. Well, actual. And we can actually extract all the log messages this way. So output event log message. And we can just say that assert equal actual expected. And that passes. Now what would be nice, like really nice, is like some tests that will make sure that this, you know, takes the right amount of time, but we have no control over time, or like there are no effects associated with actually doing the assert or the delete. So until we have like a thing that will evaluate a single command, I don't think we can very easily mock time here. So we just have this. So what does the client look like again? We have a main in the client, I think. So let's just look at it really quickly. I'm actually gonna commit this, like, add logs in interpreter, and let's test everything. So the client ignores the messages. It just takes the final result So I think we can change that. We can actually like do an eval map, maybe. So if you have an output event that's a log message, we can just log it using, I guess, just print line. So console of f, print line. Let's do something like this. And I'm gonna be fancy, and I'm actually gonna add like a color to the info message. Or maybe not. Let's just keep it this way. It's already fancy enough. Console. And yeah, eval map. Is there an eval tab? There is. And in other cases, I want just IO. Sorry, just nothing like duplicative unit. Rethrow. I don't want this yet. And I want the last or error thing. That is an F. What's that signature? Yeah, that just returns like the effect. Cool. And that's currently an output event. Yeah, I'm gonna collect. Wait, that's actually nice. So what I can do is I can keep this like if get output event, get result. I can keep this like on the stream this way, I think. Because we have this eval tab, like we do our effects here, but then we ignore all the log messages, all the other things, and we just take the result. Of course, this is going to like ignore failures, which is not really nice. We'll need to do something about that. So maybe catch failures. We should do something about this later, but I don't know if we'll have the time. Anyway, the result is an either. Yeah, we wanted to rethrow that, I think. And convert to hex. That's cool. We can try to run all of that, and I think we are able to, yeah, like run this. Like run the client with a server, like a one-off server. I don't want to test, I want to run. And we're gonna run build on the current context. Steve.json, I think that's our build. So we have an absurd command. We can add another one like a delete. What's the problem here? Yeah, and just delete a key. That should do like 2 logs. Yeah, we have an info absurding and info deleting. And we have a result. That's pretty cool. Now I think we can do the colors. We could actually do the whole thing like this, but I want to leave this for another time. So yeah, I'll bring this back again. So what we did here is just like showing the log messages. Yeah. So that's our new achievement in this episode, and yeah, I think we can actually cut it short here. This, like the next episode will be the last. We'll change the output, like pretty output. We'll add some colors in there. Some Unicode characters, and we'll add a parser for the Steve.json format. Like we'll change this format to something more like a Docker file and start parsing it this way. I think this will be enough to finish the series, and also enough for a full episode. So yeah, this is what we did here. I'm actually gonna change the order here. And yeah, so this is it for today. Thank you for watching. I hope you enjoyed this, and I'll see you in the last episode, which will come out soon. And yeah, this is it for now. Thank you very much for watching again. Please remember to let me know what you thought in the comments, and yeah.